All right. So, hello everyone. I'm Dr. Franklin. I'm an assistant professor at Norfolk State University, and I just happen to teach statistics most semesters that I'm there. And I'm doing this tutorial to help folks that are struggling with conducting and calculating the standard deviation. So during this tutorial, I'll be elucidating some of the steps that you need to take in order to calculate a standard deviation efficiently and accurately. Okay, so in order to do this, we're going to use an example at the end of one of the chapters in the textbook that we're using for the semester. So the textbook is Essentials of Statistics for the Behavioral Sciences. This is by Gravetter and Walnall, and this is the 8th edition. Okay, so this only lines up with the 8th edition, but the example will still be relevant even if you don't have the textbook. But I'm hoping you have the textbook. Specifically, the example that we'll be using is the one on page 117. And we're going to be coming from example 18. So page 117, example 18. And it reads as follows. Calculate the sum of squares, calculate the variance, and standard deviation for the following sample of n equals 4 scores. So keeping that detail of samples in mind is going to help you decide whether or not you're using sample standard deviation formula or the population standard deviation formula. So they told us sample. So they gave us n equals 4 scores. So we're working with 4 scores here. And the specific scores they gave us 7, 4, 2, and 1. Okay. So these are the raw scores that we're going to be working with. And in order to solve the problem in its completion or in its entirety, we need to get the sum of squares, the sum of squared deviation scores. We need to calculate the variance. And we need to calculate a standard deviation as well. Okay, so as discussed in lecture, the main point or the focus of sum of squares and variance is just to allow you to be able to calculate the standard deviation. So ultimately, this is what you're going to want to calculate, and these just serve as numerics that you calculate en route to getting the standard deviation. Okay, so these are the main things that we'll be calculating during this tutorial. And let's just go ahead and list out the definitional formula that I told you guys we'll be using this semester for the standard deviation. So S means standard deviation. Then we got a sigma. We have X, which stands for a raw score. Capital M, which stands for the sample mean. Then we have square. All right. That's going to be over n minus 1, or our degrees of freedom, which tells us how much variation is allowed in our data set in terms of how many numbers can vary. And then that's going to be all enclosed within a square root sign. Okay. So this is the definitional formula that we're going to be using. And let's go ahead and list out the steps to calculate the standard deviation. One is calculate the mean. Okay. So in order to do any of the parentheses up here, first thing that you got to do is know what that mean is, right? So you're going to calculate the mean first. Then afterwards, you're going to calculate the deviations. So deviations speak to something differing from something. So we're calculating deviations. In particular, we're going to find out how far each one of these raw scores are from the sample mean that we're going to calculate in step 1. Okay, so we calculate the mean, then we're going to calculate the deviations. after we calculate the deviations, we're going to square the deviations. Okay. So the reason why we're doing that is because if we add up all of those deviations, we're going to get a donut shaped looking number, and that's going to be 2. No, it's going to be 0. Okay. Why? Because that mean is the center of the data, and all these scores will balance out around the mean. So we know that we're going to get zeros. So because of that, we have to square all of our deviation scores. After we square all of our deviation scores, we're going to add up all deviation scores. Which will give us our sum of squares. Okay. So again, all of this is being calculated en route to getting the standard deviation. Then 5, what we're going to do is, we'll just say divide step 4 by n minus 1. Okay. Or our degrees of freedom. Okay. So divide step 4 by n minus 1. And when we do that, what we're doing is calculating the variance. So we're getting the average squared distance that all of these raw scores are from the sample mean. Okay. So once again, we're calculating this en route to getting the standard deviation. Then 6, we are going to take the square root, step 5. Okay, so take the square root of step 5. So here we're calculating variance. Here we're calculating standard deviation. And just to back up to step 4, here we're calculating, you guessed it, sum of squares. Okay. So all of these steps, guys, that I've listed out here, you'll find is up here in this formula. Okay. There's the sample mean right there that we have to calculate. Then there's the deviation, x minus the sample mean, right? Then we square those deviation scores. Then we add up all of those deviation scores. Then after we add up all those square deviation scores, we divide by n minus 1. And then lastly, we take the square root of it all to get our standard deviation. Okay, so knowing these symbols are really important, because if you don't know it, it's the equivalent of looking at hieroglyphics and not having a frame of reference for understanding those symbols. So even though you're ambitious and you're trying to understand, ultimately, if you don't know what the symbols mean, you won't acquire anything from looking at them. Okay, so let's move through this problem of calculating the standard deviation. Okay, so our first step is calculate the mean. So that means taking 7 plus 4 plus 2 plus 1, which will give us 14. Okay, so we're summing up all the raw scores to get the mean, one of the first steps. Then afterwards we do 14 divided by 4, which will give us 3.5. So 3.5 is our sample mean. Okay, so we have effectively done step 1. We've calculated the mean. Okay, now after that, what we're going to do is we're going to do deviations for each one of these raw scores. All right. So 7 minus 3.5 will give us 3.5. 4 minus 3.5 will give us 0.5. 2 minus 3.5 will give us negative 1.5. And 1 minus 3.5 will give us negative 2.5. So what we just did, we calculated the deviations. What we just did was we found out how far each of these raw scores are from a sample mean. Okay, but what we ultimately want is the average distance that all of these scores are from the sample mean. So we almost, just like the mean is a summary statistic in terms of taking into account every raw score and knowing the center of the data, the standard deviation is a summary statistic as well. Now, with that being said, we can't go the same route of adding all of these up and divide them by 4 because, once again, in our numerator, what we would get is a 0. So 3.5 plus 0.5 is a positive 4, and then negative 1.5 plus negative 2.5 is a negative 4. So if you added both of those up, positive 4 plus negative 4, you'd get a big, fat, hulky, you guessed it, a 0. So we can't go that route. So what we have to do is square each one of these deviation scores. So we're going to square 3.5, we're going to square 0.5, we're going to square negative 1.5, and we're going to square negative 2.5. Okay. So when we square 3.5, we get 12.25. When we square 0.5, we get 0.25. When we square 1.5, we get 2.25. And when we square 2.5, we get 6.25. Okay. So we have just squared our deviation scores. All right. So we did that. Now, step 4 is adding up all of those deviation scores. So 12.25 plus 0.25 plus 2.25 plus 6.25. Adding all of those up will give us 21. And that is the sum of squares. Okay. So we have calculated our sum of squares, or our sum of squared deviation scores. Okay. So we've done step 4. Okay. So moving along, step 5, we're going to divide step 4 by n minus 1, or we're going to calculate our variance. Okay. So that would be 21 divided by 3. 21 divided by 3 would give us 7. Right? So we have just calculated our variance of 7. Okay. And that means that we have done step 5. Taking care of that. So we got one last step to go. And that is taking the square root of 7. Okay. So if we take the square root of 7, we will get 2.645. Now, I like for you all to round to the hundredths place. Okay. Which means that to the right of that number, if this number is 5 and higher, you're going to take 4 to 5. However, if it's 4 and lower, you're going to leave 4b. Okay. So since we got a 5 adjacent to this 4, I want you to round up. So this is going to make this numeric 2.65 as the standard deviation. Okay, so we have taken care of step 6, and we have 2.65 as our final answer for problem 18 on page 117. Okay, so just a recap about the standard deviation. Standard deviation is the average distance that raw scores are from the sample mean. And in calculating the standard deviation, it's important for you to have the sum of squares and the variance. Ultimately, you're going to need these in order to eventually calculate a standard deviation. We're using the definitional formula to calculate a standard deviation. There's lots of different formulas out there to calculate a standard deviation. In regard to calculating a standard deviation for the sample size that you're using, or a sample in general, excuse me, these are the steps that you can take. Calculating the mean, calculating the deviations, squaring the deviation scores, adding them all up, dividing step 4 by n-1, then taking the square root of step 5. And these steps that I've listed out are in this formula that you see here. But in order to see them, it's important that you know the symbols. Okay? So that ends this tutorial for calculating a standard deviation for a sample. I hope this is helpful. Let me know what you think. See you soon. Bye-bye.